Good, good afternoon, everyone. Today, I will be walking you through the journey of monolith to microservice architecture. This is one of the most important shifts in modern software development. We will talk about why microservices emerged and how they are designed, their challenges, solutions like observability and resilience. At the end of this session, you will have a clear understanding of how companies like Netflix, Amazon, and Uber run a scalable systems. First, we are going to discuss about what is monolith versus microservice. Let's start with the basics. What's the difference between a monolith and a microservice? A monolith is a single unified code base. All this one is called a monolith. Monolith is a single unified code base. All features like user management, orders, payment, shipping are packaged and deployed together. So, inside this monolith, that's going to be inside the monolith. There is going to be all these functions like programming and everything are packaged and deployed to going easy to start with. Scaling becomes painful. As a small change in one area requires redeploying the whole applications. But microservice, on the other hand, this is microservice service. Break down the application into smaller independent services, user service, order service, payment service, shipping service. So this is user service, orders, pay, ship service. Microservice, which break down the application into smaller independent service, user services, order services, payment services, shipping services. Each service can scale independently, uses its own database, and be deployed by different teams. Which do you think is easier to start with, monolith or microservice? Go deep dive and understand more about this, and you can have the answer at the end of the session. Designing microservice isn't just about cutting code randomly. We use domain-driven design, DDD, to identify bounded contexts. For example, an order context is separate from payment context. Order context is separate from payment context, inventory, and shipping. This way, each microservice maps to a real business domain. Teams can own different contexts without stepping on each other's code. This reduces coupling and increase autonomy. So let's discuss this a little more deeper. Okay. So basically, all these services are coming under one monolith. All these categories functions are coming under one monolith. That is user orders payments or under all are running under one service. So this is going to take a lot of much time. Uh, if anything changed in the user, we have to change in orders, payments, shipping, and everything. So it's going to, if for small scale applications, monolith is something we can use. But if it's going to be like 10 to 15 services, we have to run all these under this, and we have to increase the scale accordingly to maintain the load management. So, for microservice, it's like the user is going to be running in another service. Order is going to run in a separate service. Payment is going to separate service. Shipping is going to separate service. So, for this, I'm going to show you something. In short, the microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanism. Often an HTTP resource API. These services are built around business capabilities. The independently deployable, I already mentioned, it's independently deployable by fully automated deployment machinery. This is the bare minimum of centralized management of these services, which may be written in different programming languages and use different data storage. So before microservice, there is a monolith. In monolith, there is also known as something called as modular monolith. And to overcome all those functions, the microservice were introduced. In the beginning stages of microservice, there is no particular way of doing things in microservice. So to given proper system for everything, uh, this guy named Martin Flower and James Lewis came together to make nine key attributes of a microservice. So basically, they are suggesting us to have these nine attributes or methodologies in your microservice to make it a microservice. But it is not necessary to have all those nine, but at least five or six is somewhat necessary so that you can call your system microservices. So I have already mentioned about monolith, modular monolith, and now microservice. There is another one called SOA. SOA is nothing but it's kind of similar to these architectures. service oriented architecture. SOA is nothing but service oriented architecture. And microservices also somewhat derived from the SOA. It's also based on services. This guy, Martin Flower and James Lewis, uh, goes on and researched every practitioner and more experienced guys in the IT industry and ask them how they created the microservice and come up with the 9 solid principles to become microservice. The key attributes of microservice, as outlined in Martin Flower's articles, are given there. First one is componentization via services. Microservices are structured as independent components or services, each responsible for specific business function. This modular approach enables flexibility, scalability, ease of maintenance. As such, as each service can be developed, deployed, and scaled independently. Try as much as possible to make your component as a services. The modularity of your system should be done using a process components, also known as services, rather than in process component implementers libraries. This is of deployment and maintenance of systems where it components are out of service, out of process service is a very valuable. Componentization via libraries is sorry, componentization via services. So componentization via services. Componentization via services. The first. So componentization means nothing but it's having a microservice. So this is our entire code. We are going to have something about the componentization. Componentization is separate and then basic like domain ideology, which is like related to payments and it's about refunds, everything will be going on also here. And same as here, something like user details are those under here, API calls are those under here. So something like DB connections or goes under here, something like that. We are going, just for example, we are going to componentization. Okay, that's what componentization is. So we are organized, second one, are organized around business capabilities. So we have to organize the microservice based around business capability. So this is so we are corporatization, we are services. So it's all should be organized around business. Each microservice is built to handle a specific business function or domain, all closely related to business functionality are grouped together to a single microservice. Instead of dividing teams or code based on technology layer, for example, front end, back end, microservices are designed and owned based on business features. So what they are saying is, instead of simply dividing it as so we say like here I have mentioned right. Simply don't do it like front end. So make it a separate service. No, back end, back end, make it a separate service. Uh, so, for example, DB. Don't make it such like it, but make it like this. I have already some of the questions I have already mentioned. Let's see. So, business capabilities. This one is going to be like dealing with user uh, login and the money. Okay, then this one is going to be like client side somewhat user switch. Clients, users are going to be in these services. Client going to be known in these services and something like that. Or a service based on domain, not on size. So it is in much about size of the service, but it is about the operation of the service, which really matter. The size of the microservice is in fixed or strictly defined. It is not about how small it is, but, but about being manageable by a small team like two pizza team. Even though services sizes may vary, they are still considered microservice for they are saying in this second attribute, they are saying do not split the microservice based on the size of the service. Not split the based on size, but split it according to you have managed the service. And to know how much the team can manage, they have come up with an ideology known as visa team. Visa team is nothing like nothing. It's nothing but a team where if they can eat two pizza, they can feel full. It's known as a two pizza team. It's just a easy way to understand. So that's what they came up. Smart endpoints and dumb points. Logic stays inside the service. Communication. So I will explain it here. Here is a service. Yes. Third attribute is smart, smart endpoints, smart endpoints, and dumb pipes. So in before small microservices, there is a SOE, service oriented architecture SOE. In that, they have make these are the things that are called known as pipes. They are saying it's are the pipes. So they are saying keep the logic inside the endpoints inside here, inside the endpoints, but not in the pipes. So making the endpoints smart and complex. In the SOA, they have make the pipes a smart one, like placing the logics in the pipe. So it keep on increasing and features and it given more and more complexity. That's what they do from microservices from SOA to microservices. So this is what my smart endpoints and dump files. The logic stays inside the service and the communication is kept simple. Microservice communicate via lightweight protocols such as HTTP or messaging queues with minimal reliance on complex middleware. The design philosophy emphasizes self-contained services that are easy to understand, test, and evolve. Traditional systems like ESBs in SAO service put a lot of logic into the communication layer. As I mentioned, they have put a lot of logic in the communication, making it complex. Sync and async communications. To communicate from one endpoint to other, we can use either sync communication or async communication. How do the service communicate? So, how do these service microservices communicate from one to another? All communication between individual services in a microservice architecture is over HTTP using REST-based services in most scenarios. All for the use of any coding language allows for the use of any coding language or framework that supports RESTful services. So all the communication between individual services in microservice are over HTTP or HTTP requests. So using REST-based services. REST-based services is a REST is nothing but a REST is nothing but a standard for API communications. Where allows for the use of coding language or framework that supports RESTful services. Team can develop microservices in any technology. However, cross communication should always be REST over HTTP. So they communicate in common way. Despite being developed in any manner, team works faster as they are in technology. They are good at. In pure microservices, any service can talk to any other microservices. Hierarchical service architecture. Here you define rules about which service type can or cannot consume other service type. So we can also design the architecture in such a way that service whichever can be accessed to this HTTP rest over HTTP requests. Okay, design in failure, which is a very important in microservice. Fourth point, we always have to design for failure. So we can't always guarantee that it's going to be success. So we always have to be designed for a failure. Microservice must be designed to tolerate failure. Any service might be unavailable at any time. Tools like circuit breakers, timeouts, and bulkheads are critical for reliance and fault tolerance. Real-time monitoring, both technical and business metric, is essential to detect and react to issues quickly. Spring Boot, unlike monolith, Distributed microservices require robust observability, like dashboards, logs, due to complex environment, emergent behaviors, distributed loggings. So, what they are saying is we have to always design for failure. So, from the client side, it's come to our control layer, from control layer to our service. So, if there is so much amount of load, it won't coming, coming. So it's become so much crowded that at some point it says I can't take anymore. At some point it says I can't, and the system shuts. So if it is shuts, it should say that it can't take anymore. So some kind of design failure is happened. So we have to give saying that okay, it's failed. That is what design for failure. We have to think what should we do when this failure occurs, or sometime we hear this one is failed. What should we do? That is very, very important in microservices. And decentralized to this decentralized data management. Each microservice has its own database or data store, allowing teams to choose the most suitable solution for their service requirements. This decentralized approach minimizes dependency and support autonomy, enabling teams to innovate and iterate independently. It makes service more autonomous and less dependent on external mechanisms. Key pointers are like every service should have its own database. Only that service is allowed to connect to that database. The other services is not allowed to connect to the DB of the other microservice. If another service wants some DB operations on that separate DB, on that separate DB, then make a call to the other service which further connects to its DB and does the crude operations. Other concepts which the database are how database managed physical multi. So this is what they are saying. Here you can see that it's monolith. There is going to be only one like database for every single for one for in microservice. There is going to be separate DB for separate all the microservices. For sometimes this you make it like it's a user. So user is going to have a separate database. For orders going to have a separate database. All the orders are going to be stored here. This database. All the user details are going to be stored in this user database. If user wants to access the DB of the orders, they should get a permission from the my user orders microservice, order service. Then they will provide uh, permission to do the operations in the orders database. Directly accessing the orders database for the user service is not allowed. So that's what they are saying. Infrastructure automation. Microservices relies on these six attributes. So infrastructure automation. Microservices relies on automation for deployment, scaling, monitoring, and recovery, enabling rapid and reliable delivery of software at scale, continuous integration, continuous deployment pipelines, CI/CD, continuous integration and continuous deployment pipelines, containerization and orchestration to streamline operation and enhance efficiency. Without this automation, would result in system flow to test and deploy. Clients would get doubts about effectiveness. Microservices infrastructure automation is nothing but microservices relies on automation for deployment. So deployments is nothing but using the DevOps to deploy the service then and there. So that we have always monitoring, and if anything goes wrong, they will do the if that's that our developer will be doing the bug changes and reference, giving the new code to the DevOps, they will be deploying it and they will be doing that is called continuous integration and continuous deployment. So updating to the current world then and there. Without this automation, the system would become slow to test and deploy. Clients also will doubt our effectiveness of the core concept of so as I already mentioned, DevOps will be doing the continuous integration deployment. Design for scale up and scale down. Scale up and scale down is nothing but increase if the load, as I already mentioned. Service one, service. These are the services basically for example. So from client side, the services starts level. There is so much of the load that we now they have to this is the service. For example, user is going to be coming here. So if he is going to be coming all the nodes of coming, the system will definitely become system is going to be become so to scaling up, auto scaling up means uh, running another service in the same way. Right? Okay. Already there is so much of load now. Go to the same service. These also use service. So that is what scaling up. Decentralized governance, decision-making authority and control are distributed across autonomous teams, empowering them to make decisions independently within the boundaries of their respective services. This decentralized approach fosters agility, innovation, and accountability, enabling team to respond effectively to local requirements and business needs. It lets the team use technology best suited for services needs. No need for service handling documents with slow and incapable relational database. No more must we use slow and legacy technology when what we really need is light and fast. Team can use best tool for the task and makes the team satisfied and as the result others and the end users should. Decentralized governance is nothing but decision making authority, control or distributed across. The team is going to make the decision, not always the higher officials, empowering them to make decision independently. So making the team do things which they want and to make the progress faster. This is a very nice one. Decentralized governance. Products, not projects. Is the eighth attribute. Microservices are treated as long-term products with ongoing ownership and responsibility. This approach encourages teams to priority, quality, reliability, and maintainability, fostering a culture of continuous improvement and customer centricity. Traditional development follows the project model. Build software, deliver it, and hand it over to maintenance. Microservice emphasizes a product mindset. The same team builds and maintains the software throughout its life cycle. The focus is on ongoing improvement of business capabilities, with the developer staying engaged with process and user feedback. So the eighth is nothing but products, not projects. It's a nice one. So before and all, there is always going to be like the developers are always going to do just build the function, build the application, build, they will hand over, build the projects and hand over to the client, hand it over to the client, maintenance will be done. If maintenance occurs, they will make it up. So that is what maintenance team they will do the rest. Will done. Now they are what they are saying is microservice is the same thing that is going to be built and maintained the software throughout its life cycle. So they can focus on what need to be improved and they can well stay engaged with the customers about the feedback also. Ninth is the evolutionary decision design. Microservice prioritize evolutionary design and incremental improvement over upfront planning and monolithic architectures. Service evolve iteratively based on feedback, changing requirements, emerging business needs, enabling organization to adapt quickly to market developments. Evolutionary design lines is nothing but microservices are always going to be improved based on the feedback get from the customers and the clients. So we are going to upfront iteratively updating the microservice according to the needs and to current technological improvements. So that is known as evolutionary design. Every service in invocation in microservice are over remote network call. As such, there is a connection system tear down bilaterally. Wire latency and every single call since is just for one call. So that is what it's all about. So these are the and two one is evolutionary. So These are all the nine attributes of the microservice. So to summarize, microservices are not just breaking things into simpler pieces. They require discipline, principles, and culture. Remember the eight principles. Remember the eight principles. A model around business domains, automate everything, hide implementation, decentralize, deploy implement, put consumer first, isolate failure, ensure. So if we follow these, microservices can be powerful enabler of scale and agility. If you ignore them, they can become a they can if you ignore them, they can become liability. Thank you so much for listening. I would be happy to take your questions. Also, leave it in the comment sections. Thank you for watching the video. Bye.